Namaskar. In this session, we will learn some basic concept of electrolytic conductance such as specific resistance, unit of specific resistance, specific conductance, and cell constant. Resistance, the resistance offered by any conductor is directly proportional to the length of that conductor, and it is inversely proportional to the area of cross section of the conductor. The resistance offered by any conductor is directly proportional to the length and inversely proportional to the area of cross section of the conductor. So therefore we can write R is directly proportional to the length and R is inversely proportional to the area A. If we solve this proportionality constant, then we get, therefore, R resistance is equal to rho into L by A. This is called as rho, and where this rho is a proportionality constant and it is called as specific resistance. This proportionality constant is called as specific resistance. Now let us rearrange this equation. If we rearrange this equation, and then we get, therefore, rho is equal to RA upon L. This A will go to the upper side and L will go to the denominator side. Therefore specific resistance is equal to R into A by L. Now let us define this rho, specific resistance. If the length is 1 centimeter and area of cross section of conductor is 1 centimeter square, then rho is equal to R into, let us put the value of A is 1 centimeter square and L is 1 centimeter. Therefore we get R is equal to ohm centimeter. Okay, so it is the resistance offered by a conductor having unit cross sectional area and unit length. This is called as specific resistance. So we can define specific resistance as it is the resistance offered by a conductor having unit cross sectional area and unit length. This specific resistance is characteristic property of conductor and it depends upon the nature of the conductor. If we change different metals, then each metal will have specific rho value, specific resistance value. Okay, from that we can identify different metals used in our electrochemistry. Next concept is specific conductance, and it is shown by letter L. S suffix is S, LS, capital L, small s. Okay, definition: the reciprocal of specific resistance rho of any conducting material is called as specific conductance. Okay, just take reciprocal of the specific resistance, then it is called as the specific conductance. So in mathematical form we can write, therefore LS is equal to 1 upon rho. 1 upon rho. Now unit of specific conductance is, as we have just discussed, the unit of rho, specific resistance, is ohm centimeter. So it will go up per ohm per centimeter, and which is equal to mho per centimeter, where this mho inverse is called as, this ohm inverse is called as the mho. Ohm inverse is called as the mho. Conductance L, it is defined as it is the reciprocal of resistance of a conducting material. Therefore this L is equal to 1 upon R. If we apply S here, then it becomes the specific conductance, which is equal to, just put the value of R in this equation, then we get, okay, R is what? Rho into L upon A. Rho into L upon A. So therefore 1 upon rho into L upon A, which is equal to 1 upon rho is nothing but the specific conductance upon A upon L. A upon L. Okay. Now next definition is cell constant. Cell constant. Okay. So the ratio of distance of separation between two electrodes that is L, and their cross sectional area A is always constant, and this constant is called as cell constant. Now what is the unit of cell constant? Okay, cell constant is equal to L upon A. Unit of length is centimeter and unit of area of cross section is centimeter square, which is equal to centimeter cancel, so 1 upon centimeter is equal to centimeter inverse. Now these are some useful formula for our calculations. So since the resistance is directly proportional to the length and inversely proportional to the area of cross section, then we can simplify this. Therefore R is equal to rho into L by A, and this rho into L upon A. This L upon A is called as the cell constant. So this resistance is equal to specific resistance rho into the cell constant. Therefore cell constant is equal to resistance upon specific resistance, and this 1 upon specific resistance is nothing but the specific conductance. So cell constant is equal to R upon rho. 1 upon rho is nothing but the Ls. Therefore a new formula is generated. Cell constant is equal to resistance into the specific conductance. Now next topic, type of conductance. Type of conduction. So there are two type of conduction. First is the electronic conduction and second one is the electrolytic or ionic conduction. In electronic conduction, the conduction is because of electrons, movements of the electron, whereas in electrolytic conduction or ionic conduction, it is conduction is because of movements of the ion. Okay, for example, the conduction in the metals. So this is the metal wire, and this metal wire conduction is because of mainly the transfer of electrons, and due to this electronic conduction is much faster than the electrolytic conductance. What happen in electrolytic conductance? Okay, this is the schematic diagram of electrolytic cell. Here the cation and anion will move towards the oppositely charged electrode, that is this cation will move towards the cathode and this anion will move towards the anode, positively charged anode, and then it will undergoes discharge at respective electrode and then current will generated. So this electrolytic conductance is slower as compared to the electronic conduction. So thank you for watching this session.